Hello everyone, my name is Dr. Kunal Patel, and today in this video we are going to see another functionalities, right? So first we are starting with the getting the diagonal of a matrix. Suppose if I want to find the diagonal of this particular matrix, then how I can find it, right? So first of all, I just need one matrix over here, right? And after that I just need to call a diagonal function, okay, and you can see that now it provides me the diagonal. Okay, now this is very simple, but sometimes it is required that I want to fetch the diagonal above the main diagonal or the below the main diagonal. So how I can find that, right? So with the use of offset parameter, I can find it, right? So for that I just need to write matrix dot diagonal, and into that I just need to apply the offset parameter is equals to 1, right? And if I apply that, then you can see I can find the diagonal above the main diagonal, that is 2 and 6, right? Similarly, if I am fetching the diagonal below the main diagonal, then I just need to write the -1. Okay, right? So you can see that you can find all these things. Okay, for your better understanding, I am copy pasting that thing over here. Okay, right? So you can see now clearly that how you can find the diagonal above and below of the main diagonal, right? So here is very simple demonstration of how you can getting the diagonal of a matrix. Okay, right? Now suppose I want to trace a matrix, right? So I want to calculate the trace of a matrix. Okay, so what is the meaning of trace of a matrix? So it is a sum of diagonal elements, and it is often used under the hood in machine learning method. So in machine learning method, this is very important, that is a trace of matrix. So how I can find the trace of a matrix? So suppose if I'm taking the same example, okay, and I'm just adding one cell below that, and I'm finding the trace of this particular matrix. Okay, and if I execute, then it's a 15. Okay, so 9 plus 1 10 plus 5 15. Okay, so this way you can find the particular trace of a matrix. Are we clear with this? Okay, the same thing you can also find with the use of sum function, but in the sum function you need to provide a diagonal, okay, and just calculate the sum of a matrix diagonal, right? So this way also you can find the trace of a matrix, and with the use of trace function also you can find the trace of a matrix, right? Now many a time this is very useful in machine learning, and especially in OpenCV whenever you are dealing with the images and all that stuff, right? So finding the eigenvalue and eigenvectors, right? So this is very important function. Okay, then how you can find the eigenvalues and eigenvectors? So first of all, let's understand what is the meaning of it. So eigenvectors are widely used in a machine learning library, and it gives a linear transformations represented by a matrix A. Okay, eigenvectors are vector that when that transformation is applied, and it only changes a scale, not the direction, right? So if you see the formula over here, AV is equals to lambda V. So here A is a square matrix, and lambda contains the eigenvalues and V contains the eigenvectors. Okay, so based on this formula, it calculates the eigenvalues and eigenvectors, right? But you don't need to worry about this, guys. If you want to find the eigenvalue and eigenvectors, then it is very easy. Thanks to the NumPy library, Okay, now suppose if I want to find the particular eigenvalue and eigenvector of this matrix, so what I can do, I can just create two variables. So first for eigenvalue and eigenvector, okay, and then I'm storing that values np dot linear algebra function, okay, and you can see there is eigen function, okay, and for which, so for matrix I want to find. Now if you execute it and if you find the individual values, right, of the eigenvalue and eigenvector, then you can see it gives us the eigenvalue and eigenvector. Okay, so it is very easy to find the eigenvalue and eigenvector with the use of these inbuilt functions. Okay guys, right? So these are the very useful functions for your machine learning. Okay, so you can just be focused on this, right, and try to learn this particular function and how you can apply this function in a real time, right? So for that functionalities, how you can apply this in a real time, please stay tuned and please subscribe to my channel for more updated videos on the same functions, right? Okay, take care, bye.